place for docket number 16-057-T06 in the matter of the application of Questar Gas Company to modify its tariff to include gas quality specifications and provisions pertaining to methane. We'll go ahead and pass around the sign-in sheet if everyone can go ahead and fill it out. And we'll go ahead and start with introductions, beginning with the gentleman on my right.
I'm Eric Horton with the division.
Peter Ashcroft, Utah Office of Energy Development.
Bela Vastag, Utah Office of Consumer Services.
Robert Moore, AG's office, representing Utah Office of Consumer Services.
Barry McCabe with Questar Gas.
Kelly Mendenhall with Questar Gas.
Jennifer Clark, also with Questar Gas.
Abby Thomas, Questar Gas.
Bill Hunt with Questar Gas.
Tony Martis with Questar Gas.
John Harvey, Commission Technical Staff.
Jordan Martin with the PSC.
Carol Revelt with the PSC.
Glenn Perry with Los Angeles Resource Recovery.
Jeff Einfeld with the division.
Doug Wheeler with the division.
Young Tuttle with DPU.
Tab Valero, Public Service Commission. And I got escaping from two-wheeler.
This is awesome!
I was thinking their analysts are getting younger.
Looking good.
Perfect. I was told that we have two people streaming, two people joining over phone. If you can introduce yourselves, please.
Michelle Bohannon, Wyoming Public Service Commission.
And Jake Emery with Wyoming Public Service Commission.
Great. Anyone else on the phone? Go ahead and turn it over to Questar.
Thank you. Actually, now that I know that Wyoming's there, I'll expand my observation, and that is here in Utah, we just wanted to recognize that I think many of you, we may end up seeing for the next 2 days in a row. We have a few technical conferences that are planned, and so we're glad that you picked this as your favorite week to deal with us. And Wyoming will be seeing you on Friday. It will be a very similar technical conference to what we will be doing here in Utah on Thursday. I think today we want this to be interactive. Kelly's going to help lead our discussion on this and provide additional input, and want to make sure that people know that we wanted it to be that type of thing. We have a few slides here. We'll be providing those afterwards. People want to be able to have those as hard copies, and we do have experts. Do you want to make sure, Kelly, why don't you introduce and tell them how all of the people that are here that they normally haven't seen and why they are around? Or Abby, maybe you just want to, why don't you guys tell a little bit about your perspective, and then Kelly, why don't you take over?
So yeah, I'll just introduce. We had a team, and I'm going to go into it a little bit. That kind of we worked through this for a couple of years to get ourselves up to a certain level of comfort. And we had some people from our own company that we used as subject matter experts. We have Tony Martis from System Engineering. We have Bill Hunt from Regulatory, and we have Abby Thomas, who's one of our pipeline engineers. So they were really important in this process, and they're going to help me as we do this presentation. So, Wyoming, I think I just sent you the presentation I'm going to give, so hopefully you get that shortly. But as I mentioned, so what we want to do today is we want to add a little color to the filing that we made on Friday, give a little more information about how this biomethane tariff came to be, as well as answer the Commission questions and then any other questions anybody had. So just want to start off with a little bit of background. So as we were approached a couple years ago to start to consider allowing biomethane on our system, and we took a little hiatus during the merger last year. 8 months, we just were busy with other things, and so we weren't able to work on this. But as we kind of went through the process, we determined a handful of risks that we identified related to biomethane, and I'm going to go through the risks, and I'm going to tell you what we put in place, we believe, to mitigate those risks so that our system continues to be safe and reliable. So the first was health risks from long-term exposure, and this is mostly from our research would come from both the customer and people actually working in these facilities, aspirating the gas with these constituents in it. if there are constituents in there that could cause long-term health concerns. We wouldn't know about it. Obviously, long-term is what is the time frame that this would occur, but we've got testing in place, we believe, that would help mitigate these risks. We've also got, we had system integrity concerns, and that's why Tony Morris was on the team, and Tony actually has brought a show and tell. So Tony's life his life's work is making sure that our pipe is safe, and that's what he thinks about all the time. And so he brought a piece, this is actually out of one of our feeder line replacements, right?
Yeah, feeder line 26.
Feeder line 26, which was just replaced, and so he's going to pass that around. You can take a look at it, and this is some internal corrosion that we found. This pipe that was pulled out of the ground.
Tell us what we're looking at, since some of us may think it's a perfect pipe.
On the inside of there, you can kind of see a lot of pattern and texture in there. That's not supposed to be there. That's some general internal corrosion that was occurring along that pipeline. This was one of the first pipelines to be taken out during the feeder line replacement teams. This segment here, and that was kind of why, part of the reason it was identified as a pipeline that needed to get removed. It was not in the best shape.
Where was it installed?
I do not know that off the top of my head, but it's not...
26? I think that's actually some of the stuff. No, sorry. Feeder line 26 was not, if it was put in 26, then that's even before our company started rolling around. Let us verify, but I think portions of this were also reconditioned, and as you know, there's different types of pipe that we're focusing on. I haven't been able to see this before.
This is steel.
Yeah, my guess is 50s or 60s.
We will follow through on that.
It was pre-1970, because everything in the feeder line replacement team was pre-1970.
Now, I do want to point out, this is not due to biomethane. No. This is just internal corrosion, but you can see if you allow constituents on your system, the kind of damage they can do. And we, as I go through our presentation, we're going to talk about some of the things we've got in place to protect against corrosion like this. Customer appliance integrity. It's something that is specific to biomethane, and what I'm talking about specifically is siloxanes. And so you can see here we have two igniters. One on the left has silicate buildup, one on the right does not. And this is caused by shampoos and soaps that when this type of material could be in biomethane, in particular if it's a wastewater facility or landfill, and so we're requiring testing to make sure that this does not get into the gas that comes from our system. And then the last is cost subsidization. So we want to make sure that these projects are paid for by the producer and that there's no subsidies in place, that the other general service customers are not paying for these biomethane projects. So these were kind of the four risks that we identified, and we went through quite a bit of research to figure out how to mitigate these risks. So the first thing we did is we conducted a peer survey. We didn't know who was doing biomethane, and our original thought was there's probably not very many people doing it. As we looked, there aren't a lot of companies that have biomethane tariffs. We were surprised to find out that there are quite a few biomethane projects in the country. And so the green states are states that have closed projects. So an example of a closed project would be, see a landfill with a electric generating station right next to it. Gas goes into the station, it's a closed system, it's really just in one area. You can see there's a lot of closed systems. And I will also say this is not a comprehensive list, this is a list of what we were able to identify. We were able to identify over 200 of these closed systems in the United States and in Canada. And then the blue states are the states that have both open and closed systems. So what we are proposing in Tariff is an open system where we're actually going to allow a producer to bring biomethane onto our system, and then that biomethane is transported on our system. So a little bit different, but we did find 12 companies in the United States and Canada who were involved in these projects, and we actually we're able to glean a lot of information from them on how they handle them. And I'll share a little bit with you about the results of that later. So we also hired Energy Technology Advancement Partners, which may not mean anything to you, but the principal of this company is Chuck Benson, who you may all remember from the Green Sticker program. He's a nationwide interchangeability expert. He has a lot of experience with biomethane tariffs, helping other companies, and so we had him kind of help us to identify some of the risks, and in particular, on Friday when we made the additional filing, you saw that we had some constituent level testing guidelines. He was really crucial or instrumental in helping us develop those guidelines. So we relied on him a lot for that. One of the things Chuck had us do was an industrial customer survey. And so I mentioned siloxanes earlier. A lot of the industrial equipment is very sensitive, and so he wanted to get a feel for what our customers had in our system. And so we sent out a survey to all the customers in our service area, all the industrial customers, and we got a pretty good response rate. So that gave Chuck an idea of the kind of equipment that was on our system, and that helped him as he helped create those guidelines, those testing guidelines for us. So any questions so far on where we're at? Okay. So let's talk about risk mitigation. So the first thing that we did, and we noticed that most of the peer companies that we talked to did this for open systems, is they required high pressure connection. So that allows for blending. And so we decided we need to do the same thing, and we thought this was important enough that we actually put it in the tariff. So if you look on page 712 of the tariff under the requirements section, requirement number 2, you can see is that the biomethane must be delivered into a high pressure system to enable blending. So that's a requirement that we're going to have, and that's one of the things that helps mitigate some of those risks we talked about. If you're blending the biomethane with geologic gas, it's obviously going to reduce the chance of high constituent levels. So that's the first thing. Second thing is to protect customers on cost, and this is another thing we put in the tariff. So you can see page 711 under additional facilities, we said applicants shall bear all actual costs, and then we go through and talk about all the actual costs required, or all the potential costs. And this will most likely be taken care of in the contract. That's what the last sentence is talking about. So we'll list out the required equipment necessary, the meters, the chromatographs, the testing equipment, the shutoff valves. That will all be paid for by the producer. Yeah.
Sorry, back on the previous slide on blending, you don't have to go back, but on, on blending, is there a percentage or some acceptable level above which you don't ever want to go of biomethane? How much biomethane in the
Yeah, I think for our standpoint, looking at it, it was a case-by-case basis. So we look at it. I don't know if you want to add anything to that.
Each project that comes to us, we're going to approve the location they can inject. So it depends how much gas they want to inject, that we can kind of then decide what the closest reasonable point to allow them to inject would be.
But the point Commissioner's probably maybe driving at is that can we handle pure biomethane, or is the WOBE such out of those?
The WOBE requirement's in the tariff, so yes, we could burn pure biomethane. But the risk is higher that we don't want to handle pure biomethane at this time.
And correct me if I'm wrong, but the equipment will be such that it will be processed to the point where it's meeting our WOBE requirements.
Yes. It has to be interchangeable when we get it without blending.
Just like any other gas from any other interconnect point.
So blending is just kind of an extra redundancy.
Exactly. Yeah, like belts and suspenders. Yeah.
Kelly?
Kelly, chemically, how is the biomethane different from the natural gas?
It only contains methane. There's no propane or butane in it, so it usually has a fairly low BTU content. And when it starts out as biogas, before it's processed to become biomethane, it has a lot of inerts in it, lots of nitrogen. So a lot of the processing takes out the nitrogen, brings the BTU up. but it also contains these trace constituents based on the feedstock.
So
And those are what are not usually present in geologic gas, and that's what we don't want in our system.
Constituent means what? And, I mean, do we think of that as like contamination, or what?
Yeah.
What is, because I know that Kelly's used the term several times
Yeah.
so
Just
far, but
something
each time you
present
use
in
it, I
the
wonder,
gas.
what does that mean?
Give him an example. Give him an example.
I know what a political constituent is.
This is not the same thing.
Yeah, I gathered that, but
So here are some of the constituents that we're gonna require testing for. So they fall in different categories. So the first category is health protective constituents, and these are carcinogenic. Arsenic, dichlorobenzene, ethylbenzene, I don't even know how to say that, propylamine, vinyl chloride. Then we've got
But tell us what those are now.
There are different chemicals that.
yeah, just,
They're
it's
cancer
yeah, okay.
Okay.
I mean, that's, I don't know.
And that
Chemicals
group can cause cancer. There's another group that can make you sick but not cause cancer.
Yeah, so the non-carcinogenic, we got antimony, I think that's like a county in Utah, isn't there? We got copper, hydrogen sulfide, lead, mercaptans, methacrolane, and toluene.
So give us a little, I mean, can't remember if we had a slide, but basically biomethane comes from about 3 different main sources, right?
At least, yeah.
Right.
And so these things we're more concerned with from landfills
That's right.
and not so much from like a dairy farm.
But wastewater as well.
Yep.
That can have anything in it.
Right, so the way this tariff, it's not just a biomethane tariff, it's a gas quality. So really, we're addressing 3 things. We're addressing gas that's coming off an interstate pipeline, which most of our gas falls into that category. And in that case, we're kind of relying on the interstate pipeline to make sure the gas quality is good. And if it meets their standards, it's going to meet our standards.
And we haven't had a tariff
No,
criterion
that's right.
to this point.
That's right. So there's kind of a twofold reason for this tariff, is to introduce what our levels are, and then also to go a step further and discuss biomethane.
And with regard to the interstate pipelines, I would add that they're not just FERC regulated, but their gas quality standards are set forth in their tariffs and they are FERC approved. And so we have a lot of confidence that they're not going to cause problems on our system. So we're happy to take gas from the interstate pipelines.
Gotcha.
Just so clear, and you're probably getting this, but so these are all going to be, the end users will be intrastate folks. In other words, this is never going to enter into your pipeline.
Right, so this will be treated like as a transportation customer, where the producer delivers the gas and says, I want to deliver the gas from this point to this point, and we deliver it. Now, are we going to deliver those exact molecules?
No, his point is that it's not going to cross state lines.
Right, yeah, right. But none of our current transportation customers cross state.
Okay, once they bring it into our Questar gas system, it stays within.
Yeah, so in other words, they're buying, they have a contract with the, whatever the landfill gas companies, whatever, but ultimately they're not getting, molecule for molecule, they're just getting it in quantity or whatever.
Right, exactly.
Okay, so, sorry, you made me think a little bit here. Technically, if we're making statements related to state lines, we serve southeast Idaho. But according to 7F, which is the FERC regulation for us to be able to move it across state lines. So maybe a molecule, depending on where we had a receipt, might find its way there. But it's all within the FERC.
But the commercial transaction is
That's right.
within,
Yeah. I think that's your point. We were being a little too definitive there. I got a little nervous.
This discussion.
This is a curiosity question. It's not technically about this tariff, but if a biomethane producer were trying to sell interstate, they would just be selling, say, Questar pipeline, or someone that they wouldn't even be touching your system, right?
Correct.
Yeah. And that's a choice they can make, yeah, if they wanted to.
Just costs a lot more in compression.
Yeah, so if you to a much higher.
And the connection fee to the pipelines probably more expensive. Okay, so I think we covered cost. Okay, automatic shutoff valves. So we have automatic shutoff valves on other parts of our other interconnects on our system. And basically what we're worried about is hydrogen sulfide and water.
Those are the two big ones.
Those are the two big ones. So basically, if you get a slug of one of those things coming through, the valve senses it and immediately shuts it in. And so that's one of the things that we will require on these projects, just like we do for any other interconnect, to keep our system safe. Water is not your friend. It's a nightmare. So water is, we definitely don't want that in our system. The other thing we're doing with respect to system integrity is corrosion coupons. So this is a corrosion coupon. It's a very low-tech technology. But basically, you've got this piece of metal, and in our case we use steel. You put it in the pipe, and steel should corrode at a normal rate or a standard rate. And so we monitor this by weight, and if the steel is getting lighter quicker than it should, then we know we've got an issue. We know we've got corrosion, and there's a problem in our system. So we'll be requiring corrosion coupons to be installed as part of this project. So that's just another safeguard, another way of monitoring what's going on in the system. And then last is testing. So this is probably, in my mind, one of the most important things we'll be doing. And I mentioned earlier we had some discussions with our peers, and what was interesting, one of the questions we had is, biomethane, is it consistent? Is it all over the place in terms of gas quality? And what we found out is once the equipment was in place and the testing had been done, most of our peers reported that they didn't have any problems. The gas was good in terms of gas quality, and also in terms of volume. It was very consistent. And so once they got through that kind of the beginning phases of it, got everything, all the kinks worked out, a lot of these projects have been online for 20, 30 years. And so it wasn't a problem. So let me just walk you through quickly, or not so quickly, our testing policy. So Abby put this awesome flow chart together. And basically, the constituent list that we filed on Friday has 3 levels. You have the trigger level, the lower action level, and the upper action level. And we'll be testing both on a per constituent basis as well as on an aggregate basis. So you may be good on each individual constituent, but when you group them together, you may be over level. You have to pass on both fronts. So basically how this works is if your gas is tested and you are below the trigger level, you'll be required to do annual testing. That one's pretty simple. Worst case, you do your testing and you're above the upper action level, you're shut off and you're required to start all over and retest. So then let's talk about lower action levels. If you are above the trigger level but you're below the lower action level, then you're required to do quarterly testing, and that quarterly testing continues until you have 4 consecutive tests below lower action level. Then it's annual testing from there on out. If you're above the lower action level but below the upper action level, you have quarterly testing, but if after 3 tests you're still above the lower action level, then shut off and retest. So that's kind of a summary of how the testing works. Did I miss anything? Do you want to add anything?
That's great.
Can I add something, again, for clarification?
Yes.
I think in our supplemental filing, we tried to make clear that the specifications Kelly is talking about were developed for the project that we're considering now. Those could be tweaked or changed depending on the feedstock of the project, the location of the project, the type of project.
And the technology available.
And the technology available. And so we would revisit this testing with each project that comes to us. And to the extent we needed to, we would seek expert advice as to what the appropriate levels are.
And that's why we didn't put this in the tariff, is because as we talked to our peer companies, they said you really need to look at it on a case-by-case basis. And to have to go in and, I just don't know how it would work if you have different testing for different producers, and it also as the equipment gets better, you may require the testing to be more stringent because it can pick up lower levels. So that's why we didn't put it in the tariff. Yeah.
I'm not quite sure I understand this. Like on the third level, you're above the action level, but you only have to test.
This one?
Yeah,
So I'm above the lower action level,
right, okay.
but I'm below the upper action level. And so, for us, someone gonna say something. For us, once you're above the upper action level, that's the shut-off point. This is kind of, marginal zone.
All of that stuff is tested quarterly.
So you wouldn't know instantaneously if they were above.
None of this stuff you know instantaneously, and that's part of the risk we're trying to manage, is there is not equipment available to test for these things continuously. But there are also things that don't cause you an immediate problem, there are things that cause you a long-term problem. So that's why we're gonna do quarterly testing on anything we find above the trigger level initially. And then if you continue to have some sort of high level of that 3 tests in a year, you'll be shut off, but if you have 4 tests below, we'll understand that you've improved your process and then we'll test it.
And controversies regarding test results and test protocols, are those, is this all just Questar's exclusive judgment, and
I'll let my attorney answer that.
No, our intention is to address it in the contract and make clear that it is, we intend to have independent testing that we can verify, and if the producer doesn't meet the requirements, we'll shut them off, and that'll be based in contract. That's our intention right now, recognizing that we do have a prudency obligation, an obligation to provide safe and reliable service. We keep all of that in mind. Our hope is it would never need to come to your attention. But we want to deal with that at the front end with the producers and make sure that everybody's in agreement. This is how we're going to proceed, and we're doing it to make sure that our system remains safe.
So, but typically it'll be a third party that's looking at the...
Right.
Yeah, we don't have any such production, and so right now, what has been proposed to us is this notion of someone else producing it and delivering it to our system. We would have your typical transportation service agreement with the end-use customer who wants the gas. But then we would have another agreement with the producer that would contain all the testing requirements. The producer would also pay for the necessary equipment. It would take care of all of those things related to the production and the delivery of the gas, sort of like an interconnect agreement, if you will.
So for this testing protocol, for a lot of things that are in pipeline tariffs, there's standards that here's how you test and here's the criteria, blah, blah, blah. Are those standards available for these kind of constituents? Is there a uniform set of procedures for testing so that you can know the quality of the data?
For the testing?
Yeah, for the testing.
Yeah, there are different standards. I think ASTM has some. We're still doing some research on exactly what protocol you order from lab to lab. But the state of California put a lot of this together. They had their Air Resources Board and the Health Department come up with levels and the testing protocol. So we borrowed the testing protocol. Our levels are similar but not exactly the same after we did our industrial survey and different things. So that's what it's based on, is the state of California initially did a lot of the research. Does that answer?
Yes.
Yeah.
Are there local companies that will do this testing for you? And you have confidence that they have the resource and the...
I think there are companies, I don't know if any of them are local.
We think there are, but we haven't exactly.
Yeah, there are definitely companies out here that have this expertise that can do this.
Kelly, can I just add?
Yeah, you might be able to add
so a lot of this testing is done at, right now, the gas testing, as Kelly mentioned, a lot of these systems are closed loop systems at treatment plants where they burn the gas in engines and they use it in boilers and that kind of thing. And they have to do this testing right now on that existing gas. So, for instance, you have wastewater treatment plants like the Central Valley Wastewater Treatment Plant. They produce biogas every day and they run their generators off it and they run their boilers off it to heat their anaerobic digesters. And they have that gas tested regularly. So the gas quality issue, the gas that you're dealing with here
actually in some ways is a higher quality, more pure gas than even what's coming out of like the ground. It has a lot of less of the impurities that you find. It has it's basically CH4, methane, and CO2. Largest it's about 65 and 35, and then you have a little bit of nitrogen, tiny bit of oxygen, and some other, but it doesn't have a lot of the impurities across a broad range that you get out of geological gas. But it's not breaking the ground. This gas is produced in hundreds of facilities across the country right now and utilized.
Thanks. Did you have a question?
Well, talking about the testing, so the automatic shutoff valves, they test continuously and apparently instantaneously, but only for water and sulfur compounds, or?
They test for anything that you can measure continuously. So we'll have an online gas chromatograph measuring all the constituents, including all the inert levels, the BTU content. We'll also have an H2S analyzer and water. So any of those things that could cause us an immediate operations problem, the slam shut valve could shut on. These things, in this testing, it can't shut on those because they are only tested quarterly.
So yeah, you got two sets of tests being
But there is equipment being developed. Like right now, there exists a siloxane monitor that can be online, but they are not yet reliable or affordable. Partly why we're leaving this in the contract, because in a few years, they probably will be reliable and affordable and will require that. Then siloxane will move from this protocol to the other one, things like that.
All right. That's all we have. I don't know, did we, I think we answered the commission's two questions.
Just out of curiosity, what is the projected penetration, I guess, of this, or do you have any initial, like comparison, or is this just like the initial thought is going to be a very tiny piece of your IRP puzzle, I guess?
Yeah, if you look at the other states, I think it'll be a small portion.
Yeah.
But I think it was going to the point, we, Questar Gas, are not looking at going out necessarily saying we'd like to buy the gas from them. But we recognize from our research that it is very common throughout the U.S. And so there's people, there's customers that will choose to want to sign up for that and say, hey, we're a transporter, this is where we'd like to get our gas supply. And so potentially we see that as probably the path that will happen.
I mean, so the real question is how many dairy farms, landfills, and wastewater treatment plants do we have close enough to, high pressure line to make it economically feasible? And we have not done that study. Glenn may have. I don't see as a percentage of our total throughput being, substantial.
I think the reality when you talk about the quantity that we're dealing with, the first phase of the project that we're developing is around 2,500 decatherms. Second phase, it could get up to around 5,000 decatherms per day. But when you look at the high pressure pipeline that you're tying into and the volume of gas that's being transported, and the fact that part of our project anyway is a cogeneration facility that will use around 1,250 decatherms, you're immediately adjacent to the pipeline. The fact of the matter is, the molecules from this project are, you'll be lucky to get them to within a half a mile outside the project. It's just not a large volume in comparison to what's going through that line every day.
Yeah.
It's a drop in the bucket.
And this project will be by far the largest that you'll probably see, because it's all about food waste. So we've got contracts on almost all of the major food waste producers, and so there won't be another one like this. There'll be, landfill guys are the ones that are doing it or already have engines. The largest wastewater plant, Central Valley, that he talked about, produces, 400 decatherms?
Yeah, 750. Yeah. It's when you look at the volumes that you're talking about in comparison, landfills can produce a large volume of gas, and landfill gas is the worst gas.
anaerobic digestion gas, which is what we need from our project, is very, very clean. Landfill gas is where you have the siloxane issues. We actually won't have siloxane issues with our gas because it's generated from food waste or organic waste, and organics don't contain siloxanes. So while we're going to have a membrane system that removes the siloxanes, that, and we'll test for them, it's not an issue with food waste because it doesn't have the shampoos and soaps and chemicals. But landfill gas, siloxanes are definitely an issue.
Is there environmental attributes or credits that are sort of offsets that you would get the Biomethane you brought up?
Yeah, there are. The market is really for renewable natural gas. So there's really two different types of buyers. Some buyers are buying it strictly for the fact that it's generated from a renewable source. So they're like solar, wind power, that kind of thing, same concept. They're willing to pay a higher price for the gas because it comes from a renewable source. That's one kind of buyer. And then the other kind of buyer is a transportation fuels buyer that's generating CNG, or compressed natural gas vehicles, which generates RINs, which is the same as biodiesel and that market. There's really two different markets for gas.
One question. You said when in your survey of open systems, you saw 12 of these. Can you just describe like what type of operations these were? I assume wastewater or what?
It's actually a mix. So I don't think we need dairy. Did we have a dairy?
We didn't. So we spoke to 12 utilities to do this. It doesn't mean there's only 12.
Right.
Most of what we talked to were landfills, actually. And some wastewater.
Yeah, did we have any dairy farms?
We didn't speak to anyone who did
So
the dairy farm. I think a lot of the dairy farms tend to be closest.
Were these going into distribution systems?
Yeah,
These 12?
Yeah, these blue states, they were going into distribution systems. Just
And there were some in Canada too.
The one in Indiana is a dairy.
Okay.
And then there's actually one in Colorado that's a food waste digester that goes into
And dairy.
and dairy. That gas gets sold goes in an interstate pipeline and goes to SMUD, Sacramento Municipal.
Oh, really? So we should have that
Yeah, we
be a
didn't pick
different
that
color
one
then,
up.
is what you're saying?
Yeah, that's a relatively new project within the last couple of years, so it might not have shown up on
Well, and if it goes to an interstate pipeline, we were really focused on
That's true,
LDC,
right.
so maybe that's why we
You're
didn't find
looking
it.
at-
But we're not claiming that we're perfect.
Oh, we're not exhaustive. Yeah.
But it gave us a level of comfort that there's a lot of this going on. I mean, this is just our own internal survey, and like I said, over 200 projects, so, yeah.
There's an interesting one in Indiana, it's Fair Oaks Dairy, and you guys probably seen Fair Life Milk, the high protein
Core
milk.
Power.
Oh, yeah, yeah.
So these guys are in, work with Coca-Cola distributed, but they do put their gas into a pipeline and it's used for CNG, and they sell it into the transportation market. And it's a dairy. It's probably one of the largest dairies in the country. We're actually there doing a fertilizer project with them right now, where we're taking the cake that comes out of the digester and making it into fertilizer.
I think the one that had the most experience was Puget Sound up in Washington. They had over 30 years experience, and they had both landfill and wastewater up there. And they produced quite a bit of gas.
Did they indicate any issues when they started up?
I think they said that they have a generation facility, and then they have a line that goes straight into their system, and they dug up part of that line, and there was no corrosion problems.
20 plus years.
Yeah, after 20 plus years, no problems, so they seem to be very positive.
In fact, the only problem we ever heard about wasn't on the utility side. It was a project in California where the producer had built a digester and didn't put heaters in, and so it wasn't producing enough gas, but that was the producer's issue.
It went bankrupt.
And yeah, it went bankrupt. And the utility said, we told them they needed to put the heaters in, and they listened to us, so it's their own fault. But as far as gas quality or issues on utilities, we didn't hear any problems, so. Last chance. Okay, thanks.
Consider this the shortest one you're going to attend this week. Actually, for those of interest, tomorrow's technical conference, Pete was asking, we do not plan to cover anything that's of a confidential nature, those that might be showing up. But Thursday's technical conference, we will, and so.
Tomorrow's the IRP, right?
Yeah, tomorrow's the IRP.
So we had the question on when was that? Pier Lake 26 was planned or installed in 1958?
I did a lot of research. We wanted to get some of this stuff.
Thank you.
We'd find that out in real time.
A lot of technology.
Yeah.
I love it.
So I have a question on this.
You supervisor